Makinig, manood, nasa teleradyo. Makinig, manood, nasa teleradyo. Teleradyo, Teleradyo Marcelo. Sa gitna ng mapanubok na panahon, magkahatid sa kakibat ay diskusyon. Sama-sama tayo, kahit magkalayo. Sa programang ito, tiyak ang pagkatuto. Teleradyo, Teleradyo Marcelo. Teleradyo, Teleradyo Marcelo. Teleradyo, Teleradyo Marcelo.
Good day, Delpilarians! Welcome to another episode of Teleradyo Marcelo, ang telearalan ng bawat Malolenyo. Don't forget to like, share, and follow us in our FB page and subscribe to our YouTube channel. I am Ma'am Jaylin M. Santos, your teacher broadcaster of the R from Junior High School Science Department. Don't forget to comment your grade and section and also the name of your science teacher for bonus points on your performance grade. No pressure, teachers and learners. All comments are welcome. Remember, this is just recitation on air. Our topic last time was about Module 4 sounds. Let us first have a recall of the concepts that you have learned about sounds or sound waves. All you have to do is to arrange the letters to form the correct words. Type your answers on the comment box. Are you ready? Let's start. Number 1, a form of energy that can be heard and travels in waves. Very good. Sound. Number 2, the highness or lowness of sounds. You are correct. Pitch. You are still listening to Teleradyo Marcelo, Grade 7 Science. Thank you for listening and commenting. Number 3, the quick back and forth movement of the particles of matter. Great! Vibration. Very good, Delpilarians. Again, type your answers on the comment box. Number 4, the blank of a sound wave determines its loudness or volume. That's right, amplitude. And that's number 5, the total number of waves produced in 1 second. You are correct. Frequency. Great job, Delpilarians. I'm glad that you still remember our past lesson. You are now ready for a lesson for today. Listen to this song.
Can go through transparent objects, but it cannot go through opaque objects. We can see things when they make light. We can see things when light shines on them. There are so many different
This song is all about light. In this module, we will be discussing about the characteristics of light. After going through this module, you are expected to explain color and intensity of light in terms of its wave characteristics. Specifically, learners should be able to meet the following objectives. First, explain that light is a form of energy and that it can be characterized as a wave. Second, recognize the ordering of the electromagnetic and visible light spectrum in terms of both frequency and wavelength. Look at the things around you. What makes you see these things aside from your eyes? Yes, it is because of the presence of visible light. Visible light makes us see the things around us. But how does light behaves so that we can see this beautiful creation? Light is an electromagnetic wave. This means that it does not need a medium in order to propagate. Light travels in a straight path. In a vacuum, light has a speed of 299,792,458 meters per second. It takes 499 seconds, or approximately 8 minutes, for light to travel from the sun to the earth. Light is a form of energy made of photons. Always remember, class, photons are the smallest unit of visible light. We have different sources of light, namely natural source and artificial source of light. Can you give one example of natural source of light? Correct. The sun. The sun is an example of natural source of light. The sun is also considered as luminous body. Always remember, a luminous body is an object capable of producing its own light. How about the examples of artificial sources of light? Very good, Alpilarians. Lamps, bulbs, and candles are examples of artificial sources of light. Different scientists spend a lot of time in understanding how light behaves. These include Isaac Newton, who believed that light behaves like a particle. Christian Huygens, who believed that light behaves like a wave. Louis de Broglie, who believed that light can be a particle and a wave. And James Clerk Maxwell, who proposed the electromagnetic theory of light. Their combined investigation enabled us to understand the behavior of light even better. Light is considered to have dual nature. Light behaves like tiny particles called photons, and it also behaves like wave. Light is formed by the vibration of electric and magnetic fields. Therefore, it is a form of electromagnetic radiation. The electromagnetic spectrum is a term used by the scientists to describe the entire range of light that exists. It is where the electromagnetic waves are arranged in increasing frequency. The different types of electromagnetic waves are radio waves, microwaves, infrared, visible light, UV light, X-ray, and gamma rays. For each type of these electromagnetic waves, frequency and wavelength are different. Observe the illustration. Which wave has the lowest frequency? That's right, radio waves. How about the wave that has the highest frequency? That's right. Gamma rays. Gamma rays have the highest frequency. The only frequency of electromagnetic waves that is visible to human eye is called the visible light spectrum. The visible spectrum is also known as white light. The most important source of light here on Earth is the sun. We call ordinary sunlight white light, but it actually includes all the colors of visible light. These colors can be revealed when white light goes to a prism. When white light passes through a prism, or something like it, it slows down a little bit and bends. Some parts of the light slow down more than others, and light spreads out into colors. If you want to see all the visible light spectrum, look no further than a rainbow. The component colors of white light include red, orange, yellow, green, blue, indigo, and violet. These component colors are arranged according to a decreasing frequency in a visible light spectrum. Light is a form of energy that travels in electromagnetic waves. It behaves like a wave, thus, it also has a wavelength, frequency, and amplitude. These properties have something to do with the special characteristics of light. Let's proceed to the characteristics of light. Do you have any idea what are the two characteristics of light? Very good, Alpilarius. The characteristics of light, intensity, and color. Let's talk about the light intensity. Light intensity is the power of light. It is the quantity that measures the amount of light illuminating a surface. Brightness is the qualitative expression of light intensity. It is the visual perception in which a light source appears to be emitting light or a surface to be reflecting light. Brightness can be expressed quantitatively using luminous intensity. Luminous intensity is the amount of light that the objects produce. This is measured in terms of candela. Brightness of light depends on how far you are from the source. Observe the following picture. In which scenario will you see a brighter light? A or B? Write your answers on the comment box. Correct. It is in picture A. The closer you are to the source of light, the brighter is the light that you will see. On the other hand, if you are farther from the source, the dimmer is the light that you will see. The intensity or brightness of light is also related to the wave's amplitude. Always remember, class, the higher amplitude corresponds to a brighter light, while the lower amplitude corresponds to dimmer light. Let's move on to second characteristic of light, which is color. As mentioned earlier, visible light is the only electromagnetic wave that can be seen by the human eye. The component colors of visible light can be seen in a visible spectrum. The color of the light depends on the frequency or wavelength of the radiation that reaches the eye. Visible light falls in the wavelength range of 400 to 750 nanometers. Observe this illustration. Based on the diagram above, what can you say about the relationship between frequency and wavelength? Write your answers on the comment box. Very good. As the wavelength increases, the frequency decreases. Time for a quick question and answer, Delpilarians. Are you ready? Number 1. Which color has the longest wavelength? Very good. Red. Next, which color has the shortest wavelength? Correct. Violet. Which color has the highest frequency? Very good. Violet. And which color has the lowest frequency? Great job, Delpilarians. Red. And now, to check how well you understand the lesson, kindly answer the assessment. Direction. Choose the letter of the correct answer. Number 1. In the visible light, which color has the longest wavelength? A. Blue, B. Green, C. Red, D. Violet. Very good. C. Red. Number 2. What will happen to the wavelengths of the colors if the frequencies decreases? Very good. B. Increase. Number 3. RGB is the basic component of white light. Which color of light carries the highest frequency? A. Green, B. Orange, C. Red, D. Violet. That's right, Delvalarian. D. Violet. Number 4. Blank amplitude corresponds to a brighter light. A. Higher, B. Lower, C. Smaller, D. The same. Great. A. Higher. Last, number 5. Which of the following is a proof that light travels in a straight line? A. Formation of clouds, B. Formation of rainbows, C. Formation of colors, D. Formation of shadow. Very good, Delpilarians. B. Formation of rainbows. Shout out to my grade 7 classes, 7 Gene, 7 2, 7 SPA 1, 7 SPA 2, and to my advisory class, 7 Ramon Barba. Today, you learned about light is a form of energy made of photons. Electromagnetic spectrum is made up of many different types of electromagnetic waves. Examples of electromagnetic waves are radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, gamma rays. We have two characteristics of light. First, intensity of light, and second, color. The intensity or brightness of light is also related to the wave's amplitude. The color depends on the frequency or wavelength of the radiation that reaches the eye. And for your assignment, answer the following. How heat is transferred? What is convection? Give 2 examples of heat transfer. That is all the time we have for now. I hope you had an amazing time learning with me today. Again, this is your Sci Educator, Jaylin M. Santos. This is Teleradyo Marcelo, ang telearalan ng bawat Malolenyo. Bye! Until next time!
Makinig, manood, nasa teleradyo. Makinig, manood, nasa teleradyo. Teleradyo, teleradyo Marcelo. Sa gitna ng mapanubok na panahon, magkahatid sa kakibat ay diskusyon. Sama-sama tayo, kahit magkalayo. Sa programang ito, tiyak ang pagkatuto. Teleradyo, teleradyo Marcelo. Teleradyo, teleradyo Marcelo. Teleradyo, teleradyo Marcelo.